So very good afternoon. So now let's start sharing my screen. All right, online guys, hope you can see my screen. All right, so thanks. So agenda, as per agenda, what we are going to cover, so we'll continue with our getting started session. No, this is big data basement. So as per agenda, we'll start with the getting started. We have a few slides still left we have to cover. So idea is holistically, we are trying to understand what is the big data and what is the Hadoop, how Hadoop is fitting into this architecture. So, and then I'll start with, once we are done with this few slides, we'll start with the big data architecture, Hadoop architecture. What is the architecture all about? Right. So before moving today, okay, yeah.
Okay, also on the projector, the left portion is not very visible.
Okay. I don't know how to adjust it. Its volume. अमित एक बार देखोगे आप प्रोजेक्टर थोड़ा घुमाओगे उस तरफ ज्यादा देख रहा है उस तरफ भाग रहा है लेफ्ट साइड में क्या मैं पहुंच जाऊंगा हाँ
Okay, you can try zooming out or something.
Zoom out करिए समझो छोड़ नहीं करना
So online guys, hold for a few minutes. We have some issue with the projector here. और थोड़ा सा ज्यादा ऊपर हो गया चढ़ जाओ उसमें हाँ रहने दो ठीक है इससे कुछ नहीं होगा अमित इस रिमोट से
ठीक है
जूम ज्यादा हो गया Oh, I don't know how to drop. I cannot find it. Taking panga already. Better? I think we can start now. Or maybe what I can try. Is it better, right? So we'll start with this notepad, right? All right, so as I said, we'll continue with our agenda. So if you have any questions before I move forward, so let me know. If you have any clarity, any doubt you have, study what we discussed, right?
In the last class you were talking about batch processing.
Right.
Can you explain it a bit?
Yeah.
What is that?
Sure. Batch processing. Right. Any other questions?
Bhupendra, what is the meaning of NAS? NAS?
Okay, right. So any other questions, you guys?
From business prospects, is there any early mover advantage if one bank is doing this big data analytics or something, and other banks are not doing? Until then, they are getting this advantage. But when all the banks are doing and all are at same level, then they will also get the same advantage, or there will be some lack of this big data analytics.
We can say competition in data science, competition in market, how big data and analytics helping organizations, right? We can convert like this. Okay, correct.
Hey, Bhupinder, one question around what change in the storage technology has either contributed to or impacting the Hadoop ecosystem?
So what change in the storage technology, right?
Yep.
That's a good question. Impact on big data. Does that make sense to your question? Thank you.
Yep.
So, any other questions, guys, if you have? So all right. So I think that's all with the questions, right? Now I can move. So first is batch processing. So let me go one step back. So if we talk about the processing, if we are talking about the processing, it's data processing we are talking about, right? So since we are talking, we are into data industry, we are talking about data processing. And the processing is the generic word you can use any organizations, right? So data processing, you can go with there are multiple ways to do data processing, right? So one is batch processing, second is interactive, and third is real time. This is the three ways to do data processing. Going forward, you'll learn what are the three ways, how we can use, what are the technologies, which is actually helping us to do these three kind of data processing. So batch processing means it's whatever the data processing we were doing so far, legacy data processing. So it's batch processing. Batch processing means, so you have a data. Let's say you have 100 gig of data, and you have a program. Program is nothing but you have written some logic to analyze, to process your data. So it's big data core. Yeah, please come. So you have a data and you have a program, and program you have written to analyze your data or do some cleansing, mining, and whatever the operation you wanted to do with the data. So you have submitted your data in one go, and now after submitting data, then you have submitted your program is processing. So you are expecting result, maybe it is processing it, and at the end of complete processing, then it is generating final output. Batch processing, you have submitted data and program all together, and after a period, after some time, then result will be complete, complete result you will get as a part of processing, right? So that is called batch processing. Now interactive processing. So interactive processing means whatever the line by line in, so you have a data, and program, rather than complete program you have written here, you have submitted complete program, but you want to do when we write the data program, right, data processing programs, there we design the data flow or data pipeline. So data flow, data pipeline. So step by step, we are going with the data flow and data pipeline, and each and every statement executing, and then coming up with the complete result in batch processing. But when we do interactive, so line by line, we are submitting program, immediately we are getting the result. Line by line, rather than submitting complete program. Either you can submit complete program in one go and then expect result after some time. That is the way to batch process. But I don't want to do that. I want to process line by line my program so that I can see what is the output of each and every statement, right? So that is interactive processing. But what is the real-time processing? Real-time, you have a stream of events. Data is coming as a part of stream of events, right? Every second, every fraction of second, data is coming as a stream of events, and that stream of events you are collecting and you are processing and you are analyzing, right? On a real time. On real time, you're getting result out of that. That is the real time, right? These are the three ways we do data processing: batch processing, interactive processing, and real time. So there is way. So the same program you can use as an interactive, you can use as a batch processing, you can use as a real time processing. There is some logic going to be changed, and by the changing of the logic, by changing of the way you are executing your program, it is converted as a batch processing or interactive processing and a stream process, real time processing. Clear? Now, next question is, do we have any question?
So I have a question. Hadoop is mostly for batch processing. It's used mostly for batch processing.
Exactly.
But by definition, direct processing seems more logical. It's like faster because in batch processing, you're eventually waiting for a result, and if some problem comes, then you'll be doing the same thing again.
Exactly.
In interactive, if anything comes up, you can just see it and rectify it.
That's correct. That's correct. By default, when we go with the Hadoop and when we are talking about Hadoop and MapReduce, it's called batch processing, right? The advantage we have the interactive processing. So batch processing, you have submitted your program, after execution of the program, then you are expecting result. And result could be correct or incorrect, right? But interactive, line by line. So interactive processing is useful when you're really doing some troubleshooting, or you're doing really some, you're building program, your program itself you're building, right? So line by line, you're troubleshooting your program, you're checking what kind of output it is generating. So there, interactive processing is very useful. But ultimately, once you have done, once you have checked your program using interactive processing, then you can collate all those line of code and then submit as a batch processing. So interactive processing, you're right, absolutely. There we have advantage. You can find out, you can troubleshoot your code, you can figure it out what is going on with your code, what is going on with the data. So there it's very, very useful. Troubleshooting and debugging perspective, interactive processing is very useful, right? I wanted to quickly explore my data discovery, you can say. There we have the interactive processing is very useful. I have a complete data. I quickly wanted to see what is inside my data, right? So I can quickly submit my own line of code and try to figure it out what is. So that is called data discovery, quick data discovery. There interactive processing is useful.
Yeah, Bhupendra. Hello.
Yes, go ahead.
Could you, give a more deep dive for real-time processing?
Okay. So real-time processing, just take an example of stock market data analysis, right? So if you look at a stock market index, right? So a stock market, there, the stock market's data, they are real-time showing the picture of how the stocks prices are going up and down, how they are maintaining all those index and all those up and down, how they are calculating. So there's some data, there's some transaction in background happening. Based on that, they are doing some analysis, and then based on that, they are coming up with the real-time changes, whether your stock is up or down. Even fraction of second, your stock is going up, your stock is going down, right? So that is possible only with the real-time data analysis, right? And either you can take example of the yesterday we were talking about e-commerce huge case, e-commerce, Flipkart, Amazon. Moment you're logging into website and on fly you're getting all those recommendations based on your shopping pattern, based on your browsing pattern. Real time they are analyzing your shopping pattern and browsing pattern of the website, and they are recommending with the different products. It's not something they have already did analysis. This is something they are real time doing, because every time you're coming up with the different perception, different kind of thought process to do shopping, right? How they are coming, how they are knowing your thought process digitally, how they are knowing. So it's only data who actually enable data science or data analytics or shopping carts to know what actually customer is trying to do. Based on that, they are predicting what is the best possible situation this customer is going to buy for a particular product. So this is the real time example.
So those like predictive model we have built up, or whatever the program we have written, so those could be changes according to real time data, or there could be like a robust model or something fixed kind of coding is there.
So the use case we are talking about, that is the predictive model getting applied on the real time data. So you can do you can say it's real time analytics, right? So you have a build, how they are coming up with the recommended market basket analysis. Market basket analysis, what is? So it's analysis which is actually recommending, if you're buying this product, probably this product is fitting best for you as well with this product, right? So this is market basket. This is algorithm. There is algorithm to do all market basket analysis, right? They have built the algorithm. Algorithm is already built, but that algorithm is going to apply the data you are submitting. How they are getting data? So moment you are clicking their website, moment you are clicking their website, and then data is getting generated, which is event data. As a part of click stream, event data is getting generated, and that data is going to be analyzed by the model they have built. And by analyzing that data, they are predicting the best possible options. That is the real time prediction. So based on the prediction, they are recommending. So there is two ways. If you go with the analytics, I'll talk about in details. Just wait for some times. As we talked about, there are ways to do a different kind of analysis.
Sure.
Exploratory, right? So exploratory analysis, predictive analytics, and then prescriptive analytics. Prescriptive analytics is nothing but which is actually recommendation engine or market basket analysis. Based on the prediction, they are taking a next best possible action. Okay. So we have long way to go. We'll discuss in detail during the different topics, right? So you'll come to know slowly. It's too early for you, a few guys. I mean, since probably analytics word would be, very new for a few guys who is actually freshers. And even we are talking about analytics, so we have already started talking about predictive and prescriptive. It's little early, but I'll go through in details. So nothing to worry, right? So if we are talking about these, buzzwords and keywords, so don't worry. I mean, this is not going to be untouched for you. I mean, guys who are really freshers, right? Who don't know about ABC of analytics. So we'll discuss in details. Slowly you'll be comfortable with the topic as well. Right, moving to this NAS. NAS is nothing but technology which is actually being used in the storage side, right? So earlier, what we used to have, every computer is coming with its own storage. Every computer is coming with its own storage. But moment virtualization came into picture, so one single physical machine can be divided into multiple computers. So that virtualization, now due to virtualizations, they have they decided to come up with the centralized storage system, so that storage system can be managed independently. And then even storage system, they are planning to have a failover, fallback, all those technologies. So there are different vendors they are providing storage technology on this area, right? So NAS is one storage technology. IBM, I think IBM. So competition in the market, how big data and analytics helping organizations. So definitely, I mean, why big data? Everyone, big data and analytics organization is speaking of. There are lots of competition in the market already. So they wanted to make themselves, better or competitive enough to capture the market. They're trying to use this analytics, right? So it's going to be slowly. We started with analytics. Now we are getting into the IoT. Now we are getting into the AI. Now we are getting into, so slowly technology is changing. New models are coming into pictures. So I would say over the period, if you have a good team, if you have your model is really good, then you have a better opportunity to capture the capture the revenue share in the market. So there is way. I mean, think whenever we build model, right? So model is having accuracy, right? What accuracy model is actually predicting something. So accuracy comes after lots of research, after lots of so lots of training of the model itself. When we build analytics model is actually getting trained. So model. So it's altogether a new area. I'm talking too early, but since you have started the question, that's why I'm sharing some insights about this. So when we do machine learning, right? Machine learning and all advanced analytics kind of things, there is two ways to do machine learning. It's called supervised learning and unsupervised learning. Unsupervised learning. So supervised and unsupervised learning, right? So there we have all models is actually falling into these categories. So how the if you go back one step, so how the robots are now coming into pictures, right? How they started responding with the different kind of answer. If you go with the Google Assistant, if you go with the iPhone Siri Assistant, right? Whatever the questions you are asking, it's responding, right? How they are responding? Because they have already trained with this data. The similar kind of data they have already trained. As much as you train, you'll respond better. These robots are responding better based on the how much they have trained. It's like a human mind and human body, right? We are learning since birth, right? We got birth. Our parents started telling about you. This is the blackboard. This is the whiteboard. This is the computer. This is that's why they are teaching us, and we are learning. And by learning, whenever we see this kind of object, we are saying, yeah, this is the computer, right? So at the robot is nothing but it's a personification of the human minds as well, right? Human minds. So human minds, how human minds interact based on the whatever we have learned in past. We have learned in past. That's why we have educated by somebody. That's why we are able to understand. This is what it's supposed to be, right? The same way. Your data, your training, whatever the models, more AI is nothing but whatever the robotics and it's coming, it's nothing but your advanced analytics, right? It's nothing but your advanced analytics. You have your advanced analytics model infused inside the metal body, right? And that metal body, what advanced analytics is doing, as much you have trained that model. So if you have trained with the better data set with the different permutations and combinations, right? They are able, and so they are able to, based on the training what they got, they are able to respond with the different situations, right?
And there was one case with Facebook that those computers were developing their own language and they were interacting, and Facebook was not able to understand.
Correct.
There is mostly artificial intelligence.
So artificial intelligence is nothing but your advanced analytics. It's nothing but your advanced analytics, deep learning technology. So analytics is having phases, right? If you go with the normal descriptive analytics, then predictive analytics. Inside predictive, you do nothing but advanced analytics. After doing advanced analytics, then it's converted as machine learning, and machine learning is further converted into deep learning. Deep learning is based on the deep learning. So how the robots recognize by looking into your picture, looking into face, they are recognizing it's you, right? Because it's again the next level of your advanced analytics, which is called deep learning. Deep learning, it means they have already educated with the deep sets of data, right? Deep sets of data. That's why they are able to respond with the right set of questions. So I would say we were talking about, so and since you pointed out the Facebook, we had a case with the Facebook where these bots, it's called bots. Even nowadays, if you go into market, right? So we are talking about chat bots or chat bots. If you go with the HDFC websites, right? So if you go with the HDFC website, even not HDFC, other websites as well.
HDFC home loan website.
No, here in fact on HDFC, so they have
auto pop-up.
wait.
It comes mostly after login. It's also there in Citibank.
Exactly. Yeah. So it's now not popping up. Otherwise,
Right.
here we have the EVA.
Yes.
They have the chatbot called EVA.
HDFC Limited. Private HDFC Limited. Instead of that.
No, whenever
and only HDFC.com. HDFC.
Whenever I open my this net banking page,
Yeah, here is.
whenever I open my net banking page, I
coming up.
look at here. Ask EVA, right? So it's called chatbots. Chatbot is behind this. There is nothing but artificial intelligence. Artificial intelligence, nothing but your advanced analytics, deep learning, advanced analytics, and then advanced analytics is nothing but deep learning, right? So whatever the questions you are asking, she is able to respond, right? Or maybe home loan interest. So how she is able to respond? Eva, how she is able to respond? Why she is responding? There is no human interaction as behind this Eva. As of now, there is no human. Whatever the questions we are asking, there is no human interaction. No human interaction at all, right? It's automatic. This is the small part of AI, you can say, right? One
solution,
right?
knowledge management solution.
Exactly. So behind these chatbots, there is nothing but your AI is playing role. AI is nothing but your advanced analytics, right? When this chatbot is getting built, right? When we even we have chatbots, right? Even Oracle do have Oracle chatbots. Microsoft do have Microsoft chatbot. Amazon has chatbots. Every organization, I mean, these big organizations, they have developed their own chatbot. When we design the chatbot for our organizations, we actually educate these machine learning with the different sets of data. That is called entity, and that is called entity configuration, right? So what we do, we actually feed the data with the different sets of data, and moment we are feeding with the data, along with the question, we are feeding answer. If this could be a question, then this is going to be answer. So that is how we train these bots. That is how we train these bots. Once we have trained with the enough data sets, then it is able to quickly, whatever we'll type, it is quickly, if there is an algorithm, it is quickly going to match your question with the already trained data sets we have provided, and by fetching the response from there, it is responding with that response, right? So that is how I would say, when we are talking about the competition, when we have the competition in the market, if everyone is actually going with the data science, in fact, every organization is, specifically banking industry, moving towards the data science. If everyone is doing data science, then how they are actually making edge to other, right? So it's depend on your how mature you have your models, how mature you have your team, how strong your analytics model you have, how much accuracy it's provide. Accuracy, when we build model, so after building models, we decide this is going to be accuracy of this model, right? It's going to be 60, 70%, 80%, 90%. It's hard to get more than the 90% accuracy, right? So that is where I do see, if you have a really good team, right, then you can say you can get a better edge with other banks, right? You can have a better opportunity to capture market, better opportunity to and position right product to the right customer. Otherwise, if I'm not looking for any home loan, why I'm getting home loan kind of promotions? I'll be annoyed. Even you're wasting your resources to promote different kind of product which is useless for me, and maybe I'm annoyed with the spam, different kind of mail. So it's better, the kind of customer looking for the product, he should get the right product at the right time, so then he can respond your query. So that is how you can better capture your market. That is where I have my perception.
So with this kind of
No. We are not going to learn about the chatbot, right? Absolutely, this is out of course. Out of curiosity, I told you about the chatbot NI, since question is around. So, but yeah, this is not part of question course at all, right?
So we advanced chatbot with one more feature, like we have provided option to provide feedback, like is this giving your answer correctly? So if they are saying yes, and we right now 4-star kind of rating for that answer. So based on these 2-3 parameters, we were selecting or filtering answer for next term.
So what is exactly this is called continuous learning. You're eventually, when my bots responded, when my models responded with the right questions, so I'm asking for the feedback from the users, whether your answer, you got your answer or not. If I got answer, if I'm satisfied, it means this is the right answer. So I'll train my model with the same information. I'll retrain my model whenever we have this kind of situation. It is supposed to respond quickly with this set of question. So that is what called continuous training of your model. So their big data is going to play a smart role. What smart role? See, we are talking about training of model, training of analytics, right? So how we are training? We are training with the different data sets. If you have a small data set, so probably you are not covering complete scenario, right? In a big data, that's why it's always called, train your model with the bigger data set is always going to give you better accuracy, right? So if you have a big data environment, there you're training your you're updating your model, so your model is going to respond better. If it's not a big data, it's small data, so probably your model is not capturing the right scenario, and it's not responding with the right answer. So our discussion is actually moving in the different direction, right? We should take a hard stuff here, right? Ashwini, no, I don't think so. As I said, chatbot is if you are able to even do your analytics, right? So this is just very first step to getting into that. But nowadays, if you go into market, right? So these organizations, Microsoft, Oracle, and AWS, they have their chatbots. They have their chatbot is not. They have already advanced analytics. Behind chatbot, there is nothing but one machine learning algorithm. So they have built it. As a user, if you really wanted to develop chatbot, what you have to do? If you just have to go subscribe their chat box, and you just have to configure different entity sets and train it, and then your chatbot is ready. Up to that extent, you can do that. It's pretty easy. But if you really wanted to build your own machine learning algorithm, so which is altogether different, it is, and this is the very first step you guys have taken towards that direction. So I cannot say you as of now, after end of this course, you would be able to build your chatbot. But definitely, it's if you subscribe with the chatbot which is already in the market, you can quickly configure it. It's not big deal. It's just GUI interface they have provided. You just have to understand. You just have to click, and you just have to do data entry operator kind of job. Your model is your chatbot ready to deploy. But the crux is machine learning algorithm behind playing the role of chatbot. So reaching there, it will take time, right? Anyway, so let's move forward, guys. We definitely have to take hard stuff. It's 45 minutes already. We are just moving around the Q&A. All right. So what changes in the storage technology and impact on the big data, right? There are lots of, that's very good questions. So changes on the storage, I would say, now we are using SAS drive, right? So now advanced computer is actually coming with the SAS disk, what we call it, SAS, right? Yeah. So SAS, so if you go with the storage technology, right? In storage, there are different kind of disk. Storage is nothing but your disk, hard disk, right? Hard disk is having a different kind of technology, but the latest technology which is actually being used, which is very fast. So why we are using fast disk? Because whenever we are interacting, my data is actually stored inside the disk, and if disk is responding with the better I/O rate, your performance would be better. The I/O of the disk is a very critical role when you're dealing with the huge set of data, right? So you can go with the latest technology which we are using in the disk, which is very fast. It's called SAS disk.
SAS or SSD?
SSD, sorry. SSD, solid machine. Yeah, SSD, exactly. SSD is actually very fast disk, which is actually responding with having better I/O. So you have to think about on which stage you are using SSD, on which stage you can live with the without SSD disk, because SSD is quite costly disk, right? So you can treat it as it's respond like a memory, right? But even if you're going with the normal disk, right? Even if we are going with the normal disk, there are technology which is actually software. By deploying those software, even you can manage, you can speed up the process of your disk. So there is open source technology which is being used. Right? So this is the kind of change you can expect. Right? So this is the open source technology again on your normal disk, right? Your normal disk in distributed environment, your normal disk can be converted into kind of memory. It is going to respond like memory speed virtual distributed storage by applying this kind of technology, right? So these are the few changes we have seen over the period on a disk side. So far we were using SATA disk, or over the SATA is pretty easy, pretty cheap, you can say. Commodity hardware, if we talk about the commodity hardware, Hadoop is known for commodity hardware. In commodity, you can go with even SATA disk, right? It is not asking for a very high performance. But if you are increasing your disk performance, definitely it is going to increase overall performance of your processing, because ultimately whatever the IO operation is actually going to happen, it is going to happen your disk. If your disk is responding with a better speed, then your performance would be better, right? But even your normal disk and normal disk, which is if you're not using SSD, or because if you go with the terabyte petabytes of data, if you're trying to use SSD, it would be very, very costly, right? Your entire infrastructure is going to be very costly. Then this kind of technology can help you to even enhance the performance of overall performance of your, right? Okay, I think that's all with the questions, right? Shall I move? Okay, we left here yesterday fault tolerance, right? Fault tolerance. Yesterday we were discussing about distributed system. We were having issue, right? If one system failed, then my entire job was failing. In distributed technology, we had issue, and we talked about John Naspet's article. If it's distributed system, it mean to fail, right? And that is for sure. So, but we should have some kind of environment who actually respond even system is failing. It does not actually hold you to not to do any kind of job, right? So your system should be such a way which actually respond, which even respond even in case of fail. That is called fault tolerant environment. So there are your Hadoop, inside your Hadoop cluster, even one node, two node, three node is failing, it is able to respond. So depend on the size of your cluster. Depend on the size of cluster. If you're going with the let's say 5 node cluster, out of 5 node, if two node is failing, then even though your data is going to process, it is not going to stop your job processing. It will get processed, right? So Hadoop actually fixed this distributed problem, which was related to fault tolerance. If any machines, if any part, or if any part or any component was failing in distributed architecture, then it was your complete job was failing. But here in Hadoop, if my out of 5 nodes, even 2 nodes is failing, even though it is able to respond with the correct result, it is not going to stop your job processing. Correct? So that is how we have the advantage with the Hadoop.
Just one question. You said if the master node allocates the work to different nodes, but if the master node fails?
I'll come to that point. That's why I skipped intensely. I skipped that particular line. I'm going to cover this. So just wait for a few minutes. So first we have to understand what is the master node, what is the node, right? Then we'll have a situation.
One question.
Yeah.
We talked about SSD. So yesterday we talked about the data blocks that we used to have data blocks in KBs. Now in Hadoop we have in MBs. So does the same difference happens in HDD and SSD?
Yeah, irrespective of your disk technology, your block system is going to be as it is in HDFS. Whether you're using SATA, whether you're using SSD, does not mean. It is going to create a block of 28 MB, 64 MB, or 128 MB. It will create that size of block.
Okay.
Right? So yeah, so for a point, I'll take it this point later on. So just wait for a minute. Why, how this complete fault on? As of now, this Hadoop is able to respond even there is any node is failing, anything wrong happening with the node. Hadoop is able to respond. But there is formula. Depend on the size of cluster, up to what level of fault tolerant your environment is. Right? As I said, if you have a 5 node cluster, it can respond it can even respond if 2 out of 5 node, if 2 node is down, even though it is able to respond. It will not hold you to stop your job. Correct? So now we were discussing about, right, study how the Hadoop is actually fitting into the DB along with the existing legacy data warehouse architecture Hadoop is fitting into. So just try to understand what is the difference between Hadoop versus DBMS, database technology, and Hadoop. What is the basic difference? I think you would be able to respond, you would understand, you would be able to correlate whatever we discussed so far. However, at a high level, so if you go with the DBMS, data is kept in relational database system, whereas in Hadoop you can keep it and it's a flat file system, right? In DBMS, can store and process only structured and tabular format of data, but here you can process any kind of data, right? If it's structure, unstructured, semi-structure, right? So in DBMS we have the fixed entity and resources available, wherein Hadoop, right, it's still growing and lots of complexity is there, and even it has resolved already complexity, and it is able to respond with the variety of data. So one important thing is, probably it can be part of your interview question, schema required on write. When we go with the DBMS, it is us, we have the situation schema on write. Here we have the schema on read. In Hadoop, we are talking about schema on read, where in DBMS, we are talking about schema on write. What is the mean of this schema and read, schema on write? So if you go with the DBMS, whenever we write the data, your schema and type of data should perfectly match. Otherwise, it is not going to, right? So you know it better. Your data type and your data should match. Whatever the data type you have defined with your schema, it should match with the data. If it's not matching, then it will create a problem. But even on ingesting data, but here in the schema on read, what does it mean? So whenever it is not actually stopping you to write any kind of data, irrespective of any kind of schema you have. Moment you will start reading your data, moment you will start processing your data, then it will enforce the schema, and then it will validate whether your schema is correct or not. So there is design philosophy behind this design philosophy. They have the design philosophy to enhance the performance of overall Hadoop architecture, right? So over the period, we'll learn how when we have the Hive session, right? So when we are talking about the schema means structured data. Structured data means somehow we are talking about DBMS or RDMS technology. So then we'll start with the Hive. Then we'll try to understand how the schema is getting enforced while reading, and where schema is getting. Even Hadoop, even if we are applying SQL query on Hadoop, right? We have to build the schema. Your file is residing as a flat file, but on top of that, we have to build a schema. If you have not built a schema, it is not going to respond at all, right? So that is in case of Hive, right? So Dipanshu, we can say, so read and write, there is, before even reading, you have to write the data, right, inside the schema. Before even reading, you have to write. If you have not written anything, right, how it is going to validate while reading, right? So point is, even if you're writing data inside your schema, it will enforce you, and which it's not matching in DBMS, it is not allowing you to do, right? But here in Hadoop, irrespective of schema you have, it is allowing you to write. It will not disturb you. But moment you will start reading, then it will create a problem, right? So that is the difference. So if we go with the DBMS, probably, so there we have to think about, if we have a use case scenario, we have to think about whether it is going to fit for RDBMS kind of technology, or it is going to be a case for big data, right? Hadoop kind of technology. We have to think there. So let's take an example. We have a small data sets. If we have a small data sets, so see, Hadoop is known for parallel processing. Hadoop is known for fast processing. Why it is doing fast processing? Because it is doing parallel processing, right? By doing parallel processing, it is doing fast processing, right? You have a small data sets, and the same data sets you are doing in RDBMS, processing in the RDBMS, and same data sets you are processing in Hadoop. So that data set may respond in RDBMS may respond better than Hadoop, right? A small data set may respond better than design. You can say design positive aspects and design negative aspects. What is the positive aspects? It's doing parallelization, right? It's by doing parallelization is actually doing fast processing. But even for parallelization, it is doing lots of internal processing before coming into parallel processing. For doing all those internal processing is actually time-taking process. If you have a small data sets, so that time it's do all internal processing. By the time you're done with the analysis in RDBMS technology, so you have to think about judiciously whether your data case is fit for RDBMS or Hadoop. If your data set is small, you don't have a long, down the line you're not growing with the data or any kind of technology, so you should definitely don't go with the Hadoop. It's not always true to go with the Hadoop, right? So that is what it's trying to say. So we have a question from Ashwini again. If you want to read the data from Hadoop for a schema-less database, then we need a schema at read time, right? So absolutely, when we are Ashwini, we need a schema at a read time when we are doing with the Hive. But even if you are going with the normal MapReduce programming or Spark programming, so it's not always required to have a schema in place, right? You can go without a schema, you can process it.
Can you say results from DBMS are more reliable and accurate than Hadoop?
No, I can't say that. This is not the right value proposition. You cannot differentiate. This is the not right way to say DBMS result is more reliable than Hadoop.
Because we are getting results without a schema, and they are doing some data sense checking and data manipulation based on some algorithm. So data accuracy can be.
See, data accuracy you can maintain even Hadoop, right? There is no difference. There is no difference at all. So my point is, this is not going to be right difference between DBMS and Hadoop. That's absolutely not right differentiation. So you have to think about the reliability perspective. Both are going to respond with the same value. Try to execute it. Both are going to respond with the same value. What you'll do, but you have to think about the important perspective is ACID on transaction management kind of perspective. If you have some data which is actually being used for ACID property or transaction management, so it's always better go with the DBMS kind of RDBMS kind of technology, right? So if you have a big data and you're not concerned about ACID or transaction management features, so it's always go with the Hadoop kind of technology. So there we'll talk about OLTP and OLAP, right? If it's OLTP kind of data, then it's always necessary go with the RDBMS kind of technology. If it's OLTP, new words I started talking about. Online guys, can you hear me? I think there were internet disruption.
Now we can hear you.
All right, thank you. There's small disturbance. All right, so that is where we have to think about, which technology you're, unless you're not completely aware about. So this is the design decision. This is the architect level decisions we have to take. If you have a complete understanding of the both perspective, they can be, then accordingly we can adopt the right technology in our design. When we design big data warehouse or data architect or data lake kind of things, then we have to think about long-term perspective and various use case and scenario perspective. So here, standardized language, we have already standardized language in RDMS technology, that is structured query language. But here there is no, it's kind of, you can say, when it's though there are lots of changes and it's already long way, it's already travel and lots of improvement we have there in Hadoop, but it's continuously evolving with the new things, right? So we can say it's in that sense, it's not having a standardized any kind of language like we have in RDMS technology, right? Sometimes you'll find someone is using Python, someone is using Scala, someone is using Java, someone is using even I can use Pig, Latin, even I can use MapReduce program. So based on the different technologies, different use case, different languages being used, right? So though there is no standardization as of now in big data, and it's continuously evolving. Lots of changes already.
Hey, Bhupinder.
Yes.
Hey, sorry, I had this question around like can you elaborate a bit more on the DBMS versus like the Hadoop? You said like there is overhead coming in, right? Because of the parallel processing. Can you elaborate a little more? Where is that overhead coming from? Is it the way the data is being accessed in the pages, or is it because of the MapReduce it is introduced,
Yeah.
or is it because of lack of indexing?
I think when we'll talk about architecture perspective, I'm going to deep dive in detail. You'll have a better understanding. But for your response, it's just because of MapReduce.
Okay.
Inside the MapReduce, there we have the two-phase map and reduce, right? So map and reduce will take its own course of action. There it is taking time. Just as of now, I stick with that answer, right? But I'm going to discuss about architecture. Well, we'll deep dive, right? Why it is taking time in, even if we are trying to process a small data set in Hadoop, it's not always good practice to process small data sets in Hadoop. It's always better to go with the RDS kind of technology. Why we are actually saying here in Hadoop, right? So answer is, as of now, it's just because of MapReduce. MapReduce, it's take own course of actions to come into the actual execution, and the time it is taking to come into actual execution is the actually performance issue. By the time, if you're processing a small data set, it's coming into its own actual execution, you're done with this processing in your DBMS technology.
Yeah, got it. Thanks.
Hi, Bhupinder.
But I'll discuss in detail. That is a very interesting topic. We have to deep dive in architecture session. Yes, go ahead, please.
Yeah, hi. Can you give one real-time example for small data sets or large data sets?
Small data sets, let's take an example. We have, let's say, 1 GB or maybe 500 MB data. 1 GB to 2 GB, maybe up to 5 GB, you can say, small data sets, right? Even 1 GB to 5 GB, your DBMS technology can respond better. 5 GB is going to be a little higher. I mean, there's there's lots of factor, but you can say to decide why we should go with the RDMS, why we should go with the Hadoop kind of technology. But as far as the small data sets, if you can think about, even 1 GB data sets, you have 500 MB data sets you have. So is it not, that's not good practice to go to process this data sets into Hadoop, right? Your RDMS technology can quickly respond, and you can better deal within RDMS technology because you are already aware about SQL. You can quickly process. And if you're going into Hadoop, you have to deal with the HDFS, you have to deal with the MapReduce, you have to deal with the Hive kind of technology, right? So if you don't have infrastructure available, you don't know ABCD of Hadoop, right? So don't pursue any kind of Hadoop architecture, and your data set is small enough. So don't pursue any kind of Hadoop architecture. It's better you can live with the RDS technology, right?
So I just want to confirm one thing. If we are talking about a small data set and if we are going with complex queries with that small 1 GB data set, and if that small query, complex query is taking so much time in RDBMS, so in that case Hadoop is better.
See, even a small a complex query you have, right? So even in RDBS, you can tune your query. There is way to you can get better performance than the Hadoop, right? Because what will happen in Hadoop, moment you submit your complex query, Hadoop has its own engine which is going to convert your query in its own format, right? So when it is going to convert its own format, it is going to apply the logic it has built into engine. That logic it is going to convert into, right? So it's standard logic. It's a standard logic, and probably that logic is not fit for your complex query, right? So there we have the Spark value proposition. Why Spark? Actually, when we'll discuss about Spark, right? Spark is saying processing of the data in Spark is 100 times faster than the MapReduce. Why? 100 times faster. That is the benchmark. Because Spark suggests it's processed data in memory. It's processed data in memory. That is one clear-cut answer. I know my MapReduce processed data in disk, but Spark processed data, all data in memory. That's why 100 times faster. Even though Spark suggests it's 10 times faster than MapReduce, even if it's not processing in memory. So Spark is actually also saying even if it's processing data not into memory, it's processing data like MapReduce processing in disk, right? Even though it's 10 times faster than MapReduce. Why? Because Spark evolved over the period and it actually fixed the bug we have MapReduce, and they came up with altogether new processing engine which is actually optimizing your all query. So to answer your query, even 1 GB data sets, your query is complex, your RDBS can respond better than the MapReduce, right? So you have to think about, pursuing Hadoop is not a small task, right? Not a small task. You have to build infrastructure. You have to have some resources available, administrator, developer, analyst, right? But if you go with the RDBS, you have already resources available. You have already infrastructure available. You don't have to really invest anything, because your data, any kind of organization, if you go, they must have some database already. They must have some SQL expert. They can write SQL. So these are the decision by looking on the different aspects we have to take while proposing different kind of technology. Clear? I think now we should move, otherwise we'll not end up with the even. Okay. So these are the differentiating factors, and I think more or less we have talked about. If you go with the Hadoop, it is definitely scalable. So advantage of Hadoop is, right, as we discussed, right, without without stopping your job, you can scale your cluster. But if you go with the legacy databases and RDBS system, if you have to scale your infrastructure, you have to stop your job. You have to stop. Otherwise, if you are scaling, you have to restart the cluster, right? Restart the services. And if by restarting, it will crash, your job is going to crash. So that is how it is scalable. Even real time, you can add node, delete node. You can do vertical scaling. You can do horizontal scaling. It's real time possible in Hadoop. How it is possible discussing architecture, right? It's flexible. Why it's flexible? You have various, like it's one negative aspects. It's not having in some standardized format, but it's advantage again. We are open to based on our capability. I am SQL expert, so I have platform to execute my SQL job in Hadoop. I'm a Java programmer. I have a platform to execute my MapReduce program. I'm a Scala programmer. I can write my Spark. I'm a Python programmer. I can write my Python. So that's why it's flexible, right? It's flexible, extensible. So, and also here we have a couple of important points when we talked about why Hadoop, right? So the main important, it's actually run on commodity hardware. That is the main value proposition. It's run on commodity hardware. Commodity hardware means it's normal hardware which you can find even in your house office, right? Even by connecting multiple machines having 8 gig of RAM, 100 gig of hard disk, you can do parallel processing. You can install a Hadoop cluster there. It's not required very super powerful or powerful computer, supercomputer, or many very heavy loaded infrastructure. And it's free. It's free. If you have enough capability, technical person within your team, you can go and adopt Apache Hadoop. You don't have to pay anything. If you are ready to troubleshoot and tackle the issues, you have a right technical team, so you can adopt free Apache open source, right? It's pretty simple. The algorithm which we have, this massive parallel processing, is pretty simple. So it's easy to learn, easy to adopt, right? It is able to respond in case of it's failing. It is able to respond automatically, right? Anything is failing. So there is resiliency already inbuilt. Up to some extent, if your component failing, service is failing, it will try to restart automatically, right? And the best part is you don't have to really perform any tape backup and all. What we are doing, backup and store archiving of the data. So why it's having, it's automatically replicating your data to multiple nodes. In Hadoop, you really don't require to do any kind of backup or DR kind of backup. I would say not DR, backup kind of features to be enabled. Because by default it is replicating your data to multiple nodes. There is standard way to replicate, and in case any node is failing, right, so data, whatever we have the data on that node, is automatically going to replicate on different node, right? So how this is replication working, what are the default replication factor, we'll discuss, right? Provide locality of execution, data locality we talked about. That's why design philosophy. All is rather than data traveling to program is traveling to data, right? It is having, even GUI, lots of GUIs we have there in Hadoop ecosystem. So even you don't want to deal with the PuTTY, you're not comfortable with the Linux interface, you can even deal with the mouse, right? By clicking mouse, by using the GUI window, GUI environment. So when we go with the GUI, there are lots of ecosystem tools we have. Hue, Apache, Cloudera Manager. Cloudera Manager is purely for administration perspective. A single administrator can manage entire cluster by single pane of dashboard. Using GUI, you really don't have to go and take PuTTY console or black and white console, right? And your data analysis, your data engineers, we have the GUI there, right? Hue, Notebook, all these ecosystem tools available. You can use that GUI to process and to submit your job. So that is why, these are the different features, and you can say that's why we can go with the Hadoop. It's a small, just interesting facts we have around the Hadoop, right? So you can find, just go through. It's just interesting facts we have here, nothing to discuss. There is not something technical to discuss here. Hadoop ecosystem, since we are talking about what are the Hadoop ecosystem tools we have therein. So these are the Hadoop ecosystem tools you can find around the Hadoop, and they have their different uses. And over the period, we are going to understand, we are going to learn what are the different ecosystem tools, how it is actually helping you to solve your data processing problem, data analysis problem, or a big data problem. So out of these tools, we are not going to deep dive each and every tool, but we'll discuss at high level, but what are the cover in course curriculum, we are definitely going to deep dive and do hands-on. Correct? So, yeah, Nox, Flume, OG, Falcon, Park, Mahod. This is Solar, Zookeeper, Hive, Phoenix, Accumulo. These are the different kind of, and they are supporting on different OS, any kind of OS you can go with. Right. So Hadoop ecosystem tools, Hadoop is actually divided into two A's, Hadoop 1.0, Hadoop 2.0. Hadoop is actually divided into Hadoop 1.0 and Hadoop 2.0. Hadoop 1.0, it looks like this. I mean, how it is. There we have this HDFS. On top of HDFS, we have MapReduce framework, right? So this is the core component of Hadoop. And then we have all those ecosystem component, Hive, Pig, and Mahot, and HBase, right? So this is Hadoop 1.0 we used to have. Now we are going to learn Hadoop 2.0. We'll continue our learning with Hadoop 2.0, but it's worth to understand what is Hadoop 1.0, what is Hadoop 2.0, and what is the basic difference. I'll discuss during the architecture. I'll discuss in detail what is the basic difference, but for your convenience, so for your understanding, and Hadoop 2.0 at a component level, we know this is a 2 component. We have core component, right? Are you right? In Hadoop we have, this is the 2 core component, but Hadoop 1.0, 1.x, we have HDFS, and this MapReduce is actually supported by 2. It's called 2 process. It's called job tracker and task tracker. Right, it's called job tracker and task tracker. Hadoop 2.0, right? So we have HDFS, but this MapReduce is actually converted with the yarn. It's converted with the yarn. Within the yarn, they have resource manager and node manager, right? So that is the difference in Hadoop 1.0 and Hadoop 2.0. But what is the technical difference? What is the technical difference? How it is fitting into? What are the advantages with Hadoop 2.0? Why we are learning Hadoop 2.0? We'll discuss in detail while discussing architecture, right? So this is Hadoop 2.0, right? HDFS, yarn, which is nothing but supporting MapReduce framework, and then we have the top of ecosystem tools. Now moving to this typical big data project, how the phase of the big data project is actually happening. Holistically, how you look in entire, end-to-end cycle inside the big data, right? So first phase is data source. Then we have the data. We have the data source. Lots of data is coming from different sources. Then first phase is data acquisition. In the first phase of data acquisition, what we are doing, we are trying to collect the data from various sources, right? Then we are storing in the storage. There we have the HDFS. And then once we store, these are the technology being used for storage. And then we have the data analysis. Then we are doing analysis with these kind of the tools. I have mentioned few tools, not to confuse. There are lots of tools we have across this area, right? Then we have the reporting and visualization. This is the typical phase of the, maybe it's not only big data analytics, any analytics, any data processing phase you can think about. Even in not a big data case, normal analytics you're doing for first you're going with the data, you're going to data source to acquire the data, to fetch the data. There you're doing all ETL, extraction, transformation, and loading. Once you have loaded in data into database, then it's some in structured format. Loaded into database means we have defined some structure on top of data. Once we have defined the structure, then we are doing all analysis, right? So analysis can be any type of analysis, be it descriptive analytics, predictive analytics, prescriptive analytics, what kind of analytics you're doing here, or doing this, right? Data discovery. Once we are done with, then the final phase is reporting and visualization, which is the final phase, which is very important. There we are talking about, this is not a data science, this is not a technology, this is the art. Though you're using technology to do visualization of data, but here you actually, you should look on art perspective, how better you can provide visual, you can present, you can convert your data into some visual appealing format, right? So without any describing, one can actually, by looking just graph, one can understand what it's talking about. And moment we go with the customer and clients, right? So there this is the phase. No one is actually talking when we have some engagement. So when we interact with the business, end user business is all top leadership. They don't talk about technology what we use. I know Spark, if you go into Spark, it's well demanded, and you'll be being technical folks, you'll be recognized, hey, this guy knows Spark, he's definitely having edge with us, and he seems intelligent. He's no machine learning, he seems intelligent, he's getting better package. But when you interact with the business folks, they don't care about whether you're doing Spark, whether you're doing Python, whether you're doing Excel. They don't bother. They're concerned about this only, how the reporting and visualizations looks like, whether it's reflecting right facts and figures, and by even looking into data set, I'm able to understand, right? So when you do this as a practice, once you're ready with the data, try to focus on the visualization part. There you can, there's lots of opportunity to grow as an individual. Professionally, you can grow, because the moment you're interacting with the business side, there you have the value. Backend team is sitting just doing or tech. They're not interacting with whatever the credit, whether it's positive or negative, you will get. And this team is actually getting, whether it's positive, if you have presented in good way, so you will be recognized. You'll be recognized by the business team. You'll be recognized by your clients. Probably you're getting paid. You're getting bonus, extra money. And they are not concerned about who actually did all background processing, whether they have applied Python, ETL, or any Spark kind of technology. So this is the very critical phase. When we do visualization, we actually we try to build a story. With the visual appealing, we try to build a story. You have to convert all visual aspect with the story when you present. So it's altogether a very interesting field. That's why I call it art. It's not a data science. It's not a. So moreover, when here we have all MBA folks, right? Their IIMs or top business classes, they are actually dealing with this phase. They're not doing, because they can better, their job is to build a story. Their job is to just make it better so that customer can understand in a better way. So if really, just based on my experience, if you really wanted to grow in this field, so this is the area you should really do excel. This is the business facing, this is the end user and client and customer facing, which actually can enhance your, over the दिन दूना रात चौगुना बढ़ने वाली बात होती है. Right. So now let's move in building block for the big data project. What are the different things you should be aware about if you're going with the big data projects, big data analytics projects? What are the important things? What are the key components you should be aware about? Right. So working knowledge on Hadoop and Hadoop ecosystems. You should be aware about what is the Hadoop and how, what are the different Hadoop ecosystem component you have and which component is actually going to fit on which place. Because one complex problem is not going to solve with the only one tool. You have to go with the mix of tools. What is happening? I mean, though every tools is claiming they can solve any kind of problem, but you'll find the problem you're trying to solve with a single tool, and probably you have to write little complex code. But the same problem other tool can just solve in a single line of code, right? So in that situation, we have to adopt mixed ecosystem tools to solve my complex problem, right? That is actually happening. Then once we have actually built my processing logic with the combination of multiple tools, then we have to create a data pipeline. We have to integrate all these tools. There we have to design my data processing flow, right? And there for designing data processing tools, again, we have the tool available in Hadoop ecosystem that's called UG, right? So comfortable with the Linux, that's also good. If you're very comfortable, if you're good with the Linux, that is going to give you advantage. But don't worry about, I'm not, these are the very standard facts I'm sharing, but if you're not comfortable Linux, so you should not worry at all. Hey, I don't know Linux, probably I came here to learn Hadoop, now I have to learn Linux. What the hell going on? So don't worry like this, right? So even you don't know Linux, we have the GUI available. You can do all jobs, necessary jobs. But as a part of course, we are going to give you quick start, right? On the Linux part, we are going to have a quick refresher on Linux. So we'll cover all those Linux commands which can actually help you. Just if you manage to go through with the content we are going to share on a Linux, if you really don't know ABCD of the Linux, and we are the content we are sharing, we are going to talk about, if you just do rectification of those commands, you're all set. You can live with even Linux, right? You really don't require to be very expert in the Linux. So that is why we have included Linux, Java, and SQL as a quick refresher. So if you guys not having background Linux, Java, or SQL, so you can quickly adopt and pace with the learning. So data warehousing knowledge, that's always good. You should have a data warehouse because most of the time we have the experience work in our Hadoop courses. But now trend is changing. Even college pass out is also, last 2-3 class we have seen college pass out of freshers also learning this technology. If they are learning, it means they are not aware about data warehouse. What is the data warehouse? But if you're experienced, you must be aware about the data warehouse. But for the fresher, what is data warehouse? What is the data mart? I am going to talk about, right? So not deep dive, right? So but you'll feel comfortable. You'll feel comfortable with the terminology we are going to use in data warehouse perspective, right? So data structure and business objective. So data structure is the standard bit experience bit fresher. You should be aware about data structure. Business objectives. So whenever we are building any data analysis, right? We are doing any data analysis projects. We should always relate whatever we are doing, it is meeting our business objective. If it's not meeting our business objective, irrespective of any kind of science you have used for data processing, it is worthless, right? So you should always try to focus whatever the analytics you're going to do, it's meeting your business objective. You should be able to relate with the business objective, right? So over the period, you would be able to understand. If you're not comfortable over the period, you'll able to understand. You'll try to learn how we have the business objective, how we can convert into technical requirements, and how we can convert technical requirements into actual technical works, right? So sometimes if we are pure technical, that's why I say this is the phase, right? This is the art. This is the art. Being technical, what I have seen, guys are actually being, if you're technical, core technical, you don't bother about this phase. You just very good in writing, code, doing data processing, very good in code. But you're doing very good in code. You have written very good program, but your program is not meeting the business we are expecting. That has been the situation. I know this is a very good guy. He can write very good program, but I have assigned some task and he has written some task very good and he's quickly responded with the task. But moment we are executing, it is responding with a different data result because he was not able to relate with the business objective. He's just thinking about technical perspective. So that is not going to fit in this case. Whatever you do, you should relate to your business objective. Then you can make some value. Otherwise, you'll be. I had there in Malaysia in my last project. The guy was having around 20 years of experience and is very confident with his technical skills. That's why he got some attitude as well, right? So we have given some task and he was doing task and we were confident he's technical, he will do that. I was very first time interacting with that guy. Based on the feedback I got with the other colleagues, so he's very technical, sir. He is very good in programming. So I have just assigned the task and given him some sprint to process it. I have some deadline as well to meet this. Based on my deadline, I thought I should assign to him because his experience, he can quickly do this job. And after assigning, I forget to ask him. I was not doing a stand-up call. I was not even asking what's your progress because I was confident because he's technical. But what happened when I asked for I had to present the next day to my bosses. Then I started 2 days before I started interacting with him. So what I have found, whatever the logic he has written very good code. Whatever the logic he has written, he was not even meeting 10% of my requirement. So that is wrong happening with the technical team, right? So that's why this point is I explicitly put here, right? You should be able to relate. That is the real case I'm saying with you guys. He's really good in programming, but that actually crapped up my entire, deadline. I was confident he can do this job very good, but he was not able to, though he's very technical, but he was not able to relate with the business objective I was trying to achieve. So for me, that guy is useless. Though even he is very technical, right? So don't be in this situation. Don't be if you're going with the data analysis. I think it's not only limited with the data analysis. It's actually valid for across domain. But here in data analysis, you should always think about the business perspective as well. It's not only technical perspective. Otherwise, you would be useless like the guy I had. Right? So, data visualization tool like Oracle BI, Tableau, ClickView, Kibana, these tools are very, very important. There you have to apply the art. You have done your data processing. I know you have done your data processing, but how the data is actually looks like, how your presentation skills. So these are the tools actually going to help you to present your data in very good manner. So you should be comfortable with the BI tools as well. See, overall, I'm talking about holistic picture. This is typically actually looking for the data science perspective, but within this, there are lots of areas you can pitch yourself. Upfront, you cannot you cannot cover entire things. You just don't assume yourself. You just try and don't assume yourself at the end of this class, I'm going to have a complete set of these skills, right? You can, but you have to start somewhere. So where you have to start, which area you are fitting into, you have to judge. You just don't try to be excel in each and every area. It comes over the period. But this is what the main requirement for the big data analytics project, right? So don't think don't try to relate you, don't try to personify yourself like in this particular entire line item I'm talking about, right? Because even in this, either you can start your career as a data engineer, you can start your career as a BIist, and you can start your career as a analyst. Various career you have, even these entire big data analytics. It's just not a single profile, it's a mix of profile. But if you really wanted to be on a higher side, like architect or data scientist, so you should comfortable with all these line items. You should be very comfortable with all these line items. And over the period down the line, if you really wanted to build your career in this perspective, so try to work on all these areas, right? So be comfortable with the analytics tool, R, Python, SAS, all these tools you should be comfortable with them, right? In big data analytics projects you should be aware about. You should be comfortable with the statistics and machine learning algorithm, right? So this is the combination of when we are going with the big data project, we have to design the team. It's not only one person, one project. We have to go with the team. So team who can take care of this, my infrastructure, team who can take care of my data processing, data mining, who is comfortable with the programming in Python, who is comfortable with the programming in Java, team person in my team who is comfortable with the analytics or a machine learning algorithm, person who is comfortable with the BI. So that is the combination of person you have to go with the big data project, right? But since you are, let's assume you're architect of that, you're solution architect of that project, right? You're project manager. So you should be generalized with all these things. You should have generalized knowledge. Otherwise, you cannot tackle these projects. So guys, anyone can give you bluff, right? So now this is the holistically we are talking about. Sometimes you go into market, right? If you're going with the POC or adoption phase, so probably your bosses can ask, what are the things we require to start with the big data project? That can be questions, and that is generic questions. What are the things we require to start with the big data projects? So this is going to be very helpful for you, right? So based on that requirement, you can design your team. Now Hadoop symbols and reasons. So this is just interesting facts. There is a story behind each and every symbols, each and every logo, right? Even we talked about Hadoop. If you look at here, pig. Why they have pig as a logo for pig Latin? Because pig Latin. Just I'm sharing this one high level. Otherwise, moment we'll talk about fluency. We'll discuss about. Just go through. We have already defined reason they have picked up these different symbols. The pig is the animal which can live anywhere, which can eat anything. So they have designed the language pig Latin which can eat anything, which can process any data. So that's why they adopted. I mean, pig is the animal which can eat anything. That's why they have picked up. So that is some interesting facts. Go with this. Who is using Hadoop? Okay. Right. So this is something you can think about. This very interesting things. You try to read line by line, try to fit into mind. You can build some story when we are going into different domain. If you took financial domain, telecom domain, retail domain, manufacturing, healthcare, oil and gas, governments, right? If we have these domains, then what are the areas we can use? What are the advantages? What we can do in terms of use cases, right? So if we are going with the financial, we can have a data. We can go with the single view of the data. So by having the single view of data, we can plan the cross sells, upsells, like we talking about even banking. So yesterday we talked about customer 360 degree, right? It's a single view of the data. of customer. So that was related to automobile, but that is not going to limited with automobile. You can go with the BFSI sector, insurance, banking sector as well. Banking is also gearing up to collect each and every information about the customer. It's not only banking details they have already with them. They are also trying to collect various information about their customer from their social life or their from their social life. Maybe it's marriage anniversary, date of birth, where you're traveling, what you're doing, what kind of interaction you, what you like, what you dislike, right? These are the information they are trying to correct. By collecting these information, they are building the single view of the information for their customer, so that they can better. And if I know my customer better, then I can sell right product to my customer, right? For example, you are my customer, you're coming into my store. I don't know ABCD about you. You started asking about just share me some, just show me some. Uh, uh, let's take an example, trouser, right? I'm looking for trouser. So maybe I don't know what if I, as a normal salesman, if you go, they're not. So if salesman is smart enough, he will start upfront asking different kind of questions to you. What kind of stuff you prefer? What is your range, right? Whether you prefer hard stuff or denim, these kind of questions they generally ask if salesman is smart enough. So by collecting those questions, what he's doing, he's trying to understand you better so that he can quickly recommend right product for you. But if salesman is not smart, so he can just start, showing different stuff, though you may not be looking for that stuff. So I think you'll be bothered. I think this store is not having the right stuff which I'm looking for. She will be. So that is the loss for the business, right? So knowing customer is always going to give a better opportunity to maximize your revenue. So there, this customer 360-degree or single view of the day customer, single view of customer is going to help you lots, and is valid to across any organization, any domain. And you can think about what are the different use cases we can think about having single view of the data, right? New account risk screens. If you go with the financial, right? Improved customer service, cross sells, upsells of financial products. So I know my customer better, right? So I can if you go with the banking industry, where there we are generating risk score against each and every customer. Now, if you now banking is targeting. If you go with the banks, right? They are started popping up. You can get loan within minute or second. Your loan is getting approved. Earlier, what it used to be, it is taking weeks or months to get your loan approved. Now they reached economy. So try to relate the facts I have shared with you guys. Facts, agility of economy. Economy is fast, moving very fast. Customer is very impatient. They can change their behavior pattern any point of time. We are impatient as a customer. Our behavior is frequently changing. And by the time my behavior is changing, if I'm not able to, as a storeman, as a bankers, I'm not able to encash that moment of the state of your behavior for that moment. I'm losing business, right? So I should be able to respond very fast. I should be able to. Let's take an example. I have a requirement to purchase some stuff. I don't have money in my debit card, right? I don't have money available, liquidity. I don't have liquid cash available with me, right? I can, though I'm interested. But by the time I'm interested, I know this person is very much interested. If I can match his requirement with the financial need, then he would be able to. So there is two opportunity for business. One for store, second opportunity for the financial, because his product is going to he's giving some money as a loan. Out of that, he's incurring some interest, right? He's earning some interest. So there is two opportunity for maximizing the business. One for banker, second for store. and you like this product, but you're not comfortable with because you don't have money in your pocket, right? So if I understand what is the problem for why you are, though you're interested but you don't have money, and as a product I have, if I can match your requirement interest with the right set of financing requirement, then you can quickly buy it, right? But by the time I'm not able to respond, I'm not able to understand your mindset, you change your mind, right? Though it's look interesting, but I don't have money, better I'll take next time, right? And you came out of the store. So it's loss for two business organization. One is banker, financier, second is store. So though there were opportunity to upsell, cross sell my product. Upsells means I'm selling my let's say TV or fridge, and then cross sells there is along with the TV and sales I'm selling my financial product, right? So there's two business opportunity I'm losing. So these are the situation how well we can respond, how fast we can respond. So if you go with the now ICICI, if I was reading article, ICICI already introduced, if you don't have cash in your ATM, you're ended up with the all cash in your debit card, and you punch your card. Real time they are analyzing your risk score, and upfront they are asking for the loan on your debit card. And within second, immediately, if you don't have cash within in your ATM or debit card, you are coming out of the coming with the cash. So how they are making it possible? On a real time, they are trying to understand they have the information about you. By the moment you punch your card, they have complete information, and they got to know what is your financial strength as of now, what is your balance as of now, and if its balance is low, really low, they can offer a front loan up to 15 lakh loan they can offer. How they are offering? On a real time basis, they are generating risk score for you on various sources. They have generated risk profile for you, and based on that risk profile they are offering different cash overdraft facility, you can say. These kind of technology is perfectly fitting. So my point is, guys, it's very interesting. You don't leave these slides, I cannot go each and every line as a huge case, right? But this is very interesting with the different domain perspective, and what are the different use cases we can build, what are the story we can build. If I'm going with the single view information, what are the different use cases we can build for retail, for manufacturing, for healthcare, for oil and gas. If I'm going to do predictive analytics, then what are the different use cases I can build? If I want to do data discovery kind of activity, what are the different? So you just keep the slide ready for you, and over the at the end of the class, when you go for the interview, if really having analytics background, you manage to deal with the analytics stuff as well, then this reference, this particular slide would be very very useful. You can manipulate your story. If you are in, let's say if you are already in telecom domain and you never have done any kind of analytics project, you just pass out from here as a big data analytics course. Now you can quickly relate your domain with the different kind of use case, and you can pitch your experience, and you can try to manipulate some experience with the with your analytics learning with the domain you have already there. So this is very interesting slides. So note it down, keep it ready for a reference, and it is going to be helpful for any in case down the line you have been asked, we are healthcare, we are going to start one project in healthcare industry. Can you build some story? What we can do in healthcare industry using the big data analytics, right? So you can often go. You really don't have to look here and there. Just go and try to. You have almost uh, 9 use cases around the healthcare industry, right? It's very interesting slide. And what are the other market opportunity outlook? You can think about using the big data and analytics, right? You can think about smart building, smart cities, automotive, Smart cities, there it's being heavily used, right? It's in smart cities. Health. So we have already covered, but these are the further we have opportunities in the market. You can try to explore a smart city. So all street lights are now being controlled by using advanced analytics, big data analytics. How they are controlling based on they are trying to save the electricity. How they are trying to save the electricity based on the temperature of the atmosphere, based on the sun rising, sun setting. They are monitoring each and every moment, and real time they are automatically controlling street light on, street light off. Even nowadays, if you go with the smart city, a smart building, so building inside, even in your office, you'll find they have installed sensor inside your building, right? So moment you are entering into office, light is automatically getting on, right? And when you are coming out of the office, then it's getting off. So by this, there is the business impact is they are trying to save the cost. Social impact is they are moving towards green energy, or maybe saving electricity, which is actually impacting social. And the business and the technical aspects, how this is actually going to happening entirely. There is all there's all you're collecting data using the sensor, and sensors data you're processing, and then you're realizing, but with the help of sensor data, you're realizing what is happening, what is not happening, and based on that, you're predicting for the next action plan, right? So that's why IoT got a very attraction these days in the market. IoT, Internet of Things. So in fact, I'm the core member of second largest IoT open source community. So we have community IoT NCR. So in fact, I'm a founder of three open source community. So one is data science community that has been taken over by Microsoft. Second is Puppet. Puppet. Have you heard about Puppet? Configuration management tool. It's being used for automation, infrastructure automation, infrastructure as a service. So Puppet, Safe, all these tools. I'm a founder of one Puppet group as well that has been taken over by Puppet itself. And one group I have IoT NCR where I'm a I'll come to that point. So one group, the IoT NCR, where we are working around the IoT. So it's open source community. This is the second largest group in Asia. So there we are discussing huge opportunities and huge cases. It's group where actually we are contributing, we are sharing knowledge, and we're doing lots of event around Delhi NCR. If you try to search IoT NCR, you'll find on Google. So there in IoT, by the time IoT started, there is a huge opportunity for the big data. IoT, without big data, you cannot do IoT IoT is kind of useless, right? So IoT generating huge amount of data. Using IoT, you are generating huge amount of data, and tackling and making some sense out of that data. There, big data you can use. The big data is helping. So these are the other, market outlooks, even in agriculture sector, even in construction sector, manufacturing, retail. We have more or less, we talked about lots of domain. Even in agriculture sector, this is again, they are trying to optimize the watering they are doing. See, we have a scarcity of the water, right? So how better we can, they in agriculture now, everyone is doing, they start lots of, as an organization, they started doing, smart farming. Smart farming means they have sensor as well as they have drone in place Inside the drone, they have the sensor in place. That drone is actually monitoring entire area, and that is sensing what is humidity, what is temperature of my particular farms, and based on that, they are trying to do watering facility automatically there, rather than sending, rather than watering entire farm, they're watering specific places. That is how they are managing. So in agriculture sector, and these are all possible with the help of only. So we are using technology along with the one. It's not only technology. It's just, you're doing all data processing, and based on data processing, you're trying to understand what is data talking about. Then you're planning your action, and it's only possible with your data analytics, data processing, and data analytics. If you're not aware, you can probably cannot do these kind of. So across any sectors, this big data and analytics is fitting across any domains. You can fit, you can use, you can build a story, you can try to save your cost. So this is the, here you will find list of companies which is actually using Hadoop already. Ecosystem provider, these are the Hadoop vendors. You can go with the Hadoop ecosystems provided we had there in the market. So far we discussed Cloudera, Hortonworks, MapR. Even I talked about Databricks, but you can find other vendors we have there. Long list of vendors. Bit and pieces they are providing. They are claiming they are providing big data environment, but you have to focus either on Cloudera, either on Hortonworks. Don't go anywhere. And some, up to some extent, even you can go with the MapR. But if you're really going with the Spark, I would suggest to try Databricks as well.
Bhupendra, how different is Cloudera and AWS to work on?
Okay, so AWS, so even if you go with the AWS, you can go with the infrastructure as a service. There you can install your Cloudera. Cloudera provides software. Cloudera provides software license. But to have this software installed, you need some hardware, computer, right? So you can go with the AWS, you can go with the infrastructure as a service, you can bare metal machines, and there you can install your own Cloudera. Even if you're not going with your own Cloudera, then AWS and Cloudera have some joint options available. So you can go with the single subscription. Cloudera on AWS, you connect with the AWS team, they can provide you single subscription as well. Or you don't want to go with the cloud AWS, you can go with the EMR, right? AWS has Elastic MapReduce. So they have their own MapReduce environment, which is called EMR. Correct? Is that clear to you?
Yeah. If we want to do this, means the assignments which will be given by you in AWS. So means how much we need to spend on the size of data? It will be depending on the size of data, or it will be depending on the processing output, like something else.
See, more or less technology perspective, they are almost same, right? They are almost same. So size of data, when we are going with the cloud, then uploading the big data on cloud, it will little challenge. You will have some challenge, right? If uploading, because you're accessing your cloud over the internet, and you have your data on local, and you try to upload, it will have some challenge based on the network bandwidth you have. But from our perspective, we don't mind. You can do assignments and projects, Hortonworks, Cloudera, or AWS, whatever you prefer, even Oracle, right? Whatever you prefer. But the support, we are fine as far as you're able to solve the assignments, because each and every technology is almost same. They're talking about same architecture, same things. And they have just done some cosmetic changes, and they're providing same kind of features. But as I said, the support, if you expect, Bhupendra, I'm having some issue with the EMR, can you help us? So there we have the challenge. But if you ask for, can you help us with the Cloudera, then I can definitely help you out. Right?
Okay, okay, cool, cool.
Right, Ashwini. But even AWS, you can go with the AWS. They have a single subscription. They have channel partner with the Cloudera. So you can go with this with the single point of contact. You can go with the infrastructure as well as Cloudera license. In Oracle, we have a Oracle Big Data Clouds. There is three flavor of big data environment. One is Big Data Cloud Service, which is pure Cloudera based. Second is Big Data Cloud Service Compute Edition, which is Apache open source, pure open source by Oracle. Third is infrastructure as a service. You can go with the Hortonworks, you can go with the MapR, and you can go with any kind of big data technology as an infrastructure as a service. Right? But the kind of maturity with the Oracle which I have found, and they have, along with that, they have lots of other big data components, big data connector, and so connector is actually very helpful. Inside the connector, you can find Oracle R for Hadoop, Oracle Big Data and Spatial. These are the few interesting connectors they have. So you can, even using R interface, you can process your data. Generally, it's available. Even using R interface, you can process your data residing inside the big data environment. Generally, it's available. But Oracle is having its own R models, R algorithm, which is tightly integrated, which can process data Hadoop inside. Tightly integrated model is fine-tuned, refined, tested. So these are some value Oracle has. I'm not here to talk about product perspective. I'm just sharing you some thoughts. You can give a try. Okay, guys. Now architecture, Hadoop architecture. This is how it looks like. We have a distributed storage. On top of that, we have processing engine. Then you can do batch interactive streaming processing, and there we have the upstream. Then side you can talk about data governance, and you can talk about the security. But what are the different components we have? So for storage, HDFS, for processing we have yarn, and then what are the different processing you can do using yarn? We have batch processing. These are the big Hive libraries is known as a batch processing. And interactive processing, you can go with the Spark. Even in Hive, for real time we have HBase, Cumulo, Storm, Apache, Spark Stream, Storm, Kafka. These are under the real time processing. We had one question related to solar, right? Someone asked for solar. I think I missed. Okay, how can we connect Apache Solar with the Hadoop, right? How we can, so if you go with the Cloudera, right? Cloudera search is already there, which is nothing but solar. It's already inbuilt, they are providing. Even in your environment, it's already provided, right? So you really don't have to worry about connecting solar with if you're going with the Cloudera environment. But if you really wanted to have open source connection, so you have to, I have not tested so far, Apache open source, Hadoop and Apache Solar, because whatever the environment I have worked so far, it's by default they have integration in place. I can check it out if you're going with the open source version Apache Hadoop or Apache Solar, how you can integrate. For that, I don't have answer right now. But yeah, if you go with the top vendor, they have already integrated. You really don't have to worry. By default, they provide along with the product license. And you know what is the use of solar? I think solar is search engine. You can use as a search engine, right? So it's open source search engine. What happened to data and logic flow when the node fails? What is the time right now? Do we need break, guys? Oh, it's already 4. I think we should go for a break. You need break?
Yes.
All right. So guys, you need break. I did not realize the time actually. So let's go for a 10-minute break today only. Right? So we are going to start again 4:17. So guys, we are back now. So we have one question. What happens to data and logic flow when the node fails? How the fault tolerance incorporate with that? This is the topic to be discussed. This is the topic to be discussed when we'll talk about architecture deep dive, how it is happening. But Dipanshu is replied almost, he's tried to attempt. This is the replication. Definitely replication is playing a very good role up to great extent in this fault tolerant, but there were lots of other things behind this fault tolerant environment. How the fault tolerant environment, how Hadoop claim fault tolerant environment, we'll discuss in detail. That is chapter we have in our architecture, right? So just wait for some time. And Hadoop architecture, batch processing, real-time processing, this is something we discussed already. But since we talked about batch processing, real-time processing, and near real-time or real-time, near real-time processing, but what are the different technology actually fitting into? What are the different technology? If we're talking about the batch processing, then there we have the MapReduce, HDFS, which is nothing but Hadoop. If we are talking about real-time, so then it's again Storm, Flink, or HDFS. But if we are talking about near real-time, you can go with the Apache Spark or HDFS. So this is how you can even differentiate product-wise. Modern data architecture. So that is called unification of the data architecture. Unification means, so you have already this data warehouse, which is on legacy database system, RDBMS systems. There we are fitting into our HDFS Hadoop with the yarn, and the rest of these source system and upstream application is same. But this is how modern data warehouse or modern data architecture, and you can say even unification of the data architecture. Even you can say this is the Lambda based architecture. This is the Lambda based architecture. So what is the Lambda? So since we initially we set the agenda, we have to discuss about the architecture perspective. What are the different architecture we have in Hadoop? So this there is basically two type of architecture we are following in Hadoop case. One is Lambda based architecture, and second is Zeta based architecture, right? So, but what is the Lambda based architecture? Lambda based architecture where we are able to do batch processing, the architecture, the environment where we can do batch processing, where we can do real-time processing, and maybe you can say even interactive processing, right? This is Lambda based architecture. The Zeta based architecture, so Zeta based architecture is definitely combination of this plus containerized environment. Containerized environment means it's Docker enabled, right? So then so you have a single environment. See, as an organization, you cannot have a multiple infrastructure or multiple cluster for different things. You can plan for single infrastructure where you can do your batch processing, where you can do your real-time processing, where you can do your interactive processing, and when you can think about this is the most preferred environment. So far, people are moving with the Lambda-based architecture. Guys are not, organizations are not comfortable with the Jita-based architecture. They have some challenge with the Docker. Docker is not, they have found, Docker is not able to fully integrate with the Hadoop environment. But however, if you have, they are moving with the containerized based architecture as well. If you have adopted Docker, Docker, what is the Docker? See, we are talking about the Docker. It's virtual machine, you can say. So far, we talked about virtualization of hardware. Now, using the Docker, we can talk about virtualization of operating system. Your operating system can be virtualized all, right? So you can go with the Jita-based architecture. The single infrastructure, your architecture should be in such a way, it should follow Jita model. If it's following Jita model, it means you have the infrastructure to do batch processing, in real-time processing, interactive processing, even you would be able to deploy your containerized environment, Docker-based applications, right? So that is the difference. But so most preferred environment, most preferred architecture is Lambda-based architecture, right? So this is what we are talking about, the modern data architecture or Lambda-based architecture. Even you can say unification of data architecture. Unification means you are bringing each and every infrastructure and data on a single place. So this is one of the important complete life cycles we have to understand. If you are able to understand, you are good to visualize the holistic picture of your entire data analysis and data processing in terms of software, hardware, and steps as well, right? So big data ETL, you can say big data ETL or big data ELT, or maybe you can say big data data engineering, right? So let's try to understand what is the different component we have therein. If you go with the organization perspective, this is the ideal scenario for big data ETL lifecycle. So what is happening? So these are the data sources we have. We know so far we talked about we can bring all sources into Hadoop. We are rather than directly loading data into legacy data warehouse. We have ported Hadoop in between source system to your legacy database. We have poured it, we have ingested our Hadoop architecture as well. So now we are talking about we are ingesting data from various sources into Hadoop. So once we have ingested data from various sources, be it archive data, batch processing, replicated data, real-time replicated data, stream data, we have ingested here. Then when we go with the ETL kind of operation, the very first thing come into mind, the hiding of the sensitive data, PII information and PCI information. If you are security compliant, if you are bank, financial organizations, and if you are healthcare organizations, you have to comply with some data security policies. So PII and PCI data. PCI means PCI data is those data which is related to financial credit card information, right? And your transaction account, all those PCI information. PI information, the information you can actually by having this information, you can identify easily records, right? Personal identifiable information, PI information. So if you go with the security norms, so these are the very confidential information. But when we do ETL, so we have to actually hide those data, so it's not visible to all user, because these are the very confidential data. Then we have the situations to mask the sensitive data. Then during the ATL, you have to mask the sensitive data. That is called masking and redaction of the sensitive data, right? So if some column or information is carrying, credit card detail, then you can hide that column to rest of the user so that they cannot access that column, right? Or you can that is called redaction. And you can even hide sensitive, you can mask those data if it's personal identifiable information, mobile number, email ID, name, blah blah. So you can mask those data set, you can replace with some junk, some unidentifiable character. So this is very important during ETL lifecycle. You have to deal with the sensitive data, the complete picture. So we have during the complete ETL big data ETL lifecycle, we have to deal with this kind of, if it's critical organizations, right? Critical data is critical or sensitive data. So you have to deal with. Now then, we have the situation of MDM, master data management. Then we have the situation of you have to perform some master data management. You have to correlate master data management. You have to process golden record of the customer. Then you have to do some data quality checks, DQs you have to apply, right? Data quality is very important. Data is not, this is the part of ETL. See, this ETL's life cycle we are talking about, before data is being analyzed, your data has to go with these life cycles. Before you do any analytics, any analysis on top of that data, your data has to go with these phases, right? So there we are performing masking sensitive data, redaction of the sensitive data, and then accessing golden records. Then you're performing some governance, right? For example, this particular table should not be visible to this team. This particular database is not accessible to this team. These are the governance and metadata management you have to do. And then you have to perform some data DQs, data quality checks, how the data, what is, you have to you have to apply some validation on top of data. And after doing all these things, and during that process, you are performing some transformation and refining process. And once you're done with this data, then you're finally dumping in the right data warehouse, right? Right data warehouse. Why we are dumping into data warehouse? You can even hold your data over here to do direct analysis on top of Hadoop. But sometimes we need to dump data in the data warehouse. Why we need the data to dump into data warehouse? Because there are a couple of visualizations tools which are actually based visualizations tool where you have built dashboard, analytical dashboard based on the data marts. So when you are building analytical dashboards, you have to build data marts. Why we build data mart? Because in your data warehouse, you have a complete data available, right? So probably your database, the dashboard you have built, which is not relevant to access entire data set. It is actually looking for set of columns or set of records, right? So what you're doing, since my dashboard is looking for set of records, set of columns, why do I expose entire data to this data dashboard? So I'll expose only that data sets. So what I'll do, I'll extract that data, that amount of data sets, and build data mart. So you can say it's mini data warehouse, which is specific to your particular dashboard, right? So if it's your dashboard is actually based on some data mart, and data mart is a concept of your legacy data warehouse or database which is relevant to RDMS, then you have the situation to dump your data from Hadoop to data warehouse, right? So this is the complete, life cycle of your ETL. ETL is very complex process. Most of the tasks. So entire, if you look at the life cycle we talked about earlier, there is acquisition, ETL, data analysis, and visualization. So ETL an acquisition is actually taking maximum time of your complete life cycle. So if you talk about time, it's almost taking 60 to 70% of your time to prepare your data. Why you're doing ETL? To prepare data, to bring data in such a structure so that it can be analyzed. If you're not bringing into proper structure, right? So what will happen? Because when we get the data is not in proper format. It's unstructured data. Some records are missing, some duplicate value are there, some confidential information are there, and we are just doing analysis on top of that. That can lead to different prediction, and that prediction can impact on your business on negative perspective, right? So before doing analysis, you have to bring your data into proper format. So there you have to perform this extraction, transformation, and loading logics. So loading is actually happening here. From Hadoop, you have done all transformation, then you're loading data warehouse into data mart, right? So this is the complete ETL life cycle. It's very interesting work to know, and you should be ready. I mean, when you go with the complete projects, then these are the areas you should be aware about. If you're going for analysis perspective, you should visualize what are the steps my data has to go, and then see, by the time you're getting into the new job profile, right? Hadoop analytics, right? Someone can ask, this is the huge case. How fast you can respond with this huge case? How fast you can respond? How much time will you take to build this huge case? So these are the inputs going to help you lot. You should visualize before solving this huge case, what are the different steps I have to perform, and it's not easy steps. So accordingly, you commit for the timeline, right? Otherwise, what will happen? Yeah, I can definitely do. If you're a very good programmer, I can respond within week, right? I can come back with the analysis within week. That's absolutely not possible. If you're saying you can respond within week, so you should also take some assumption. Assumption like I'm assuming data is already cleansed, data is already prepared, and if you have given data, I can analyze within week, right? If data is not analyzed, so you should also think about, right, all these steps you have to go through with this data. So that is where maximum time is taking, right? And if you don't have Hadoop, you have Oracle data, or I mean, I'm not specific to Oracle, any RDBS database, and you have huge amount of data, then whatever the time you are spending with each and every stages, that is going to be multiplied with the time your RDBMS system will take to process, right? Then your timeline is increasing. Rather than responding in weeks, so you probably need months to respond, because your data is quite huge and it is getting processed by your RDBMS system, and it will take time, right? Then what you can do, you can process your data here. All data engineering and data mining activity you can do. Once you're done with the processing, you just download here, right? So you can expedite here the overall processing time. If it's taking 5 hours, you can make it 1 hour, provided you have right infrastructure. Even you can bring to seconds or minutes using Sparks, right? You can further optimize it. So this is where Hadoop is actually helping you with your ETL lifecycle. So guys, I think that's all with this getting started session. Now we'll start with the architecture. So before moving Hadoop architecture, before moving to Hadoop architecture, if you have any question, any clarification, we can quickly discuss. What is the time? Okay. Commodity hardware. We have 30 minutes almost. Commodity hardware. Any guess around the commodity hardware?
Anything that's easily available through different vendors.
Right?
And
Absolutely right.
can be shared based on some costing.
Can be?
Can be shared based on some costing and among the users,
Can be shared based on the costing.
among different users.
Okay. What other? Online guys, what is the commodity hardware?
Hardwares which are available easily within home or office.
Very straightforward answer. The hardware which is easily available
Off the
across
shelf.
all vendors, right? And it's not having a very so if you that's one definition. Other one more line you can add in commodity hardware. It's not superpower. It's not super powerful computer. It's just having good amount of memory and processor. You can go with the you can treat as a commodity hardware. So your hardware, your system can vary from low processing to high processing, right? If you go with each and every vendor, they have low processing to high processing, right? Even high processing software is available with almost all vendors. If you go, they can give you, but that does not mean they are commodity hardware, right? Commodity hardware. So having it's not you try to relate with the processing power, right? Processing power means you have the hardware which is really easily available even within hardware which is you using your office purpose, normal office routine jobs. You can treat as a hardware, commodity hardware. Hardware which you are using your normal office job, you can treat as a commodity hardware. Nowadays, if you go with the hardware in your office, even your laptop probably it must be more than 8 gig of RAM, right? At least 8 gig of RAM, the latest laptop which we have in office. If you go with the desktop, 16 GB, 20 GB is normal desktop if you have in office, right? So that desktop can be treated as a commodity hardware. And by connecting those desktop over the network, you can build Hadoop cluster. And Hadoop can run very well on those even normal desktop as well. It does not require data centers, servers, blade servers, or powerful machines, or any supercomputer. If you go with the Microsoft SQL, Oracle databases, they recommend at least this should be minimum capacity. Your hardware should be strong. Your hardware OS should be strong. You have minimum this GB RAM, that much of core size of your database. Then you can go with that is recommendation. But Hadoop is not having such kind of recommendation, right? You can go with when you have 4 gig of machine. Even if you have a 4 gig of your laptop and you can connect all multiple 4 gig of laptop over the switch, you can process even 100 gig of database, right? 100 gig of data, you can process it. So let's
Bhupendra, have you tried using multiple laptops and building a cluster?
yeah, I have tried with the desktop, not laptop actually. So in my previous organization, there were lots of desktop was actually about to dispose of. They have cycles like over the 3 years, 2 years they dispose. So I managed to do POC. So we have hardware really available. So all desktops connected over the switch, and we managed to run the show. It was commodity desktop, and it was having 16 GB of RAM, i5 processor, and they are just connected over this normal switch, right? Five node cluster we built.
So if we say
Hey,
master and slave, so master is not shareable, but these commodity hardwares are shareable.
Master, so even commodity, see, shareable is a different concept. Shareable, when we go with the network connectivity, we have to connect each and every machines over the network. They should be able to talk freely, but they don't really share the data. Whatever the data I have on one laptop, it's not dependent on the other laptop data, right? So that is called share nothing architecture in Hadoop. See, that's why they maintain this fault tolerance, right? So if I have one data on one machine, it has gone down, it is not impacting other. If it's having some sharing concept, then definitely it is going to impact on other node as well, right? So Hadoop actually suggests share nothing architecture, right? Any question?
Hey, Bhupinder, one question on this ETL life cycle. So you're showing like something. You're showing a storage layer or like a data acquisition layer that's coming from OLTP labs, and then you're processing and finally distributing it through some channels, web pages or mobile or whatever, right? Now, in an architecture like this or in a layout like this, you probably increase the processing speed using Hadoop, but does that mean I can actually just scale the system in its entirety? Because like now I have multiple hops coming from like relational data to Hadoop and then moving it back into relational. And if my process is synchronous, right? For asynchronous batch processing, like day jobs, night jobs, I mean those things are understandable. But if it is a synchronous thing, what would be the weak points here?
So see, actually, you pointed very good points. Definitely, we have multiple hops here, right? Sometimes it's lead to total. It actually impact overall processing times. Multiple hops means, what does it mean, guys, for you? So we have different connection point with the different data sets. Like here we are coming data is coming on Hadoop, then one hops we have here, we are doing something, then second hops we have here, we are getting some, not second hop here, we have master data management, then governance, we have then third hops, we have DQs, then we have this data warehouse. These are the different stages of data you are going, stages of data your data is going through. So now point is scalability. If you see, so we have to think about the situation, right? Situation, if you think about my data sets is pretty small enough. My data set is pretty small, so definitely I can directly dump my data over here and perform within the database. You have all features available within the database. You have single, and in the single place you can do all DQs, you can do all security, you can do all masking, or you can do all data governance within the single place, right? But now we are talking about big data case. Then your data is growing, and this data is not even so we are talking about the big data case, we are talking about real-time data case. So in that situation, this database is not able to respond properly. I have to go with the Hadoop kind of architecture. If we are going with the Hadoop kind of architecture, then we have to deal with these many hops. There is no choice. But what you can do, you can optimize overall processing time. So these hops are not going to impact as much if you manage to optimize overall processing time. Let's take an example of you are doing 1 terabyte of data here, and it is taking maybe 10 hours to process 1 terabytes of data. You're processing, you're doing all operations, all ETL jobs you're doing within single stage, as a single stage, right? Be it ETL, be it DQs, be it security, be it governance, you're doing on a single place with 1 terabyte of data. And it is taking at least 10 hours to do entire things. But when we are going with the Hadoop, you can optimize altogether 10 hours, you can bring it down to even 1 hour, right? Even here, but if we have the hops, maybe it is contributing half an hour, these hops, then ultimately you're making overall execution, it is taking it is not definitely going to take a 10 hours. It can take maybe 4 hours or 5 hours. So net impact you are making with the overall processing with the less, you are reducing by 5 hours, right? So 5 hours, even 5 hours is a pretty good amount, as far as the processing concern. So based on the different requirement, as I said, and different data sets, you have to think about what would be best architecture. But if we are really talking about big data sets, then we have to go with these hops. There is no choice. You have to go with these hops. But now your point, now it's all your understanding and your processing logic, what kind of processing, how you're optimizing it, how fast you're doing it. You can optimize your processing time, right? So ultimately it is impacting your overall processing time. Here you're taking 10 hours, but even those hops contributing a small processing time, but you have optimized overall processing time here with the Hadoop. So net impact is you're reducing with the 5 hours. And the best part is, even if you want to further optimize, you can just scale. This architecture is anytime, any point of time, you can scale up. You can bump up resources, right? You can bump up resources without impacting your existing job. It is not going to impact. So you can further optimize by providing extra resources. So I can just allow me a few more minutes. It's real huge case we have with the banking. The bank is actually there. I'm designing this data lake based architecture. So bank is having huge case. Bank has to share a daily report to RBI. There is mandate, right? Every bank has to share their daily reports to RBI, and there is timeline. By this time, you must have to share the report. If you're not sharing reports, if not sharing data, then you will be penalized, right? And if you are continuously making mistake, then probably it costs you your cancellation of banking license, right? So now that bank is very much concerned, the existing architecture they have multiple hops available, right? And then they have all data is quitting. They have the hops as well as they have data warehouse. So all data they are processing in their data warehouse. Data warehouse, it will take its own course before giving final data to downstream application, financial applications to generate the reports. And that is contributing almost 12 hours. And sometimes job is failing, bank is not able to submit the report to RBI. And they were very much concerned, and they are asking to come up with some kind of an architecture which can actually optimize, which can do all, which can optimize, which can reduce overall processing time, right? So then there we have placed the Hadoop data lake kind of architecture. We are bringing all data from across resources into single place, and there we are massaging. Even for massaging, rather than using SQL, traditional SQL language, I'm going to use a Spark for ETL. So I'm further going to optimize over a processing time. And then ultimately, the time it was taking there in data warehouse, it is going to be reduced by at least 1/10. If managed to reduce this 1/10, I'm confident, and we are confident we can reduce it 1/10. And if we are not even reaching 1/10, if we manage to reduce 1/5 as well, right? That is the great achievement. And now the bank would be able to submit their financial report on time to RBI. That is overall proposition, and with this kind of Hadoop kind of or data lake kind of data architecture we have. And the second point, right? Second very important point, so by having this, you're going to have unification of the data. You're going to have a complete view of the data. So you can further, our bank are heading towards the data science practices, right? So data science and data model can be better if they have the big data with variety of data, so that their model can be trained with the big data with the variety of data. So that model can respond better, predict better. So that can be possible only if you have a consolidated view of the data. And that consolidated view, it's not only consolidated view, your system would be able to respond if you have submitted any kind of analytics model here, it is able to respond and it is able to process it, right? Hope that makes sense to you guys. Any so I'm not sure what's your name. I mean, whenever we talk about, please speak your name so that I can relate. So yeah.
Hey, I'm KK Krishnakant.
Krishnakant, that makes sense to you?
Yeah, I got it. I think probably we can talk when we really get in to the level of detail, especially say for data reads and writes, going from relational to Hadoop, and then going back into relational, whether you use Scoop or whatever in between. Like we can probably talk a little about the optimizations, potential optimizations there.
Yeah.
And the other thing that I would love for probably learning is a little more on the transactional consistency, especially if we are using this for a real time.
Yeah, we can definitely. It's too early to talk about. We are going to discuss in detail even architecture perspective. So, however, if you want to further clarify, discuss, we can take it offline. So that's not an issue. But yeah, we are going to, when we discuss about architecture perspective, most of your question is automatically going to cover. But the kind of what I was trying to emphasize on the architecture perspective and overall value proposition perspective, are you guys convinced with this architecture? If you have any doubt, why you convinced means, are you able to visualize and convert into your thought process? If you have any doubt, let me know, because these are very important things we are discussing. These are based on the real use cases.
Regarding the visualization and analytics, if we are doing our query at this that end, so can it be interacted with Hadoop directly, or need to go first this data analysis and query step?
Right. So there could be a situation where your visualization can even directly connect to Hadoop. Right, you can fetch, you can execute your query, you can fetch record directly from Hadoop. Your visualization is very well, they are supporting Hadoop connectivity, so you can do visualization. But when we go with the analytical dashboard, which is based on the data warehouse and data mart, then they have to pause with these steps, right?
I want to avoid this step if suppose if RBI is implementing Hadoop, so instead of getting data from different banks, they can directly link with all the banks, and instead of asking data, they can run report and they can get data anytime.
Government of India is already doing this project. They are heading towards this. I don't want to name it, but this vision is already there in charter. So that's why they are trying to stop all money laundering activities and fraud activities, which is happening so far. You have seen the SBI, how much SBI posted current loss, Q3, highest ever in 17-18 years, because of inability to do these kind of, and there is manual intervention overall. So manual intervention, someone is getting, someone is manually verifying, approving your loan application without maybe how much we are correct, right? So these are the things. It's already in government charter. They are trying to cut all manual intervention, and they're trying, and this can be possible with this kind of technology only. Right, so that is where that's why, or why do you think why our Aadhaar card is getting linked with each and everything? Exactly. So that is the reason, because they want to, even you are going for a shopping, if you're traveling, whatever you're doing, your one unique key is there, which is by following that unique key they would be able to identify. And by following these unique key, they are trying to do network analysis. You can do network analysis. You can find out how many people are connected to which particular people. What are the money flowing from which source to which direction, how. So this is in government charters. They are already heading towards these areas, but it's long vision. It will take time. It's not easy to implement. That is, these are the small steps we are actually every day hearing. Right, government is now planning to integrate your voter ID card with the Aadhaar card. Then they will try to streamline the election process, and how it can be streamlined, right? So these are the technology which is actually helping, right? So government is having, I mean, we have interacted. That's why I've said use case, right? They were actually, PMO is very much, very aggressive, and they are now doing like kind of, CEOC. They are managing entire, they are not going with the new paperwork. They are going with proper digital and proper presentation power, proper analytics way. Every decision now they are taking based on the data driven. And latest Chandrababu Naidu, have you Chandrababu, Andhra Pradesh? Yeah. Andhra Pradesh government is very, very aggressive, and they are excel in this area. They have already implemented lots of things there, and real time they are monitoring each and every activities for each and district level officers activities as well.
They have implemented completely.
Now, one use case you can talk about legal, right? So big data and analytics is getting used in legal processing, legal proceedings. How they are using, they are trying to, whatever the cases, cases has been so far, they are converting into digital, and they have the reference, they have the master data based on this situation, based on this different circumstances. They are trying to relate which best fit dhara or use case is going to apply for this crime. So it will not take long proceedings, right? So these are the ways, just because of these technology enablements, we were able to think these kind of situations, these kind of scenarios. So you have a huge opportunity, but it's not, but always take analytics along with you. You cannot only, you can live without analytics. I cannot deny, but it make more interesting in your profile if you take along with the analytics, right?
Bhupendra, if government is working in this area, so they must be hiring big data analysts. So,
Yeah,
means where I can find these jobs.
you can go. There are lots of government don't have their own resource pool. They are already tendered with the multiple organizations. Be it if you go find in TCS, Wipros, all these folks, Infosys, they are engaged. They are working very closely with the government.
The one I know is Social Corps in Delhi. So I know about them. They work with the government. They work with UP government. So
Exactly, Delhi government, Delhi. So even I cannot talk about specifically any polishing, but yeah, polishing is also going with the smart polishing. All state government, they are heading with the smart polishings. Smart polishings means, so they are also going to manage all data-driven activities using the network analysis. They can predict where is going to riots happen, and before riot is happening, they are deploying the right resource, right forces there, so that they can restrain riots and crime. So in Western countries, they are already started. They are already using, but in our countries, we are already heading towards these areas, and these are the projects related. So there is government's concept of smart cities, right? Why we have this smart city? Because they wanted to relate each and everything to consolidate a single place, so that they can take a better decision. If you have a better data coordination, so you can better respond with the action plan. Earlier, nowadays, we have each and every organization is living isolated. If you go with the fire department, they are living isolated. They have their own set of course of action. If you go with the police department, they have their own set of action. If you go with the municipal corporation, they have their own set of course of actions. So if you have something to deal with these three organizations, so nowadays you can assume how much time, how much it is painful to get the work done from all three departments. Now, using the smart city concept, they are going to be centralized. If there is any casualties or any crime is happening, they are going to they are coordinating with the centralized way, and they are performing in that is the value proposition. There we have the smart city concept. They wanted to bring each these unit into single place. So I'm not pro to Modi, but someone when everyone is talking about this government is not doing anything. The kind of policies, the kind of step they have taken, it will reflect. It will take time, because if you go with if you're working in a single organization, if you wanted to process your expense to be approved, at least it will take weeks to be get approved, right? If you're working in a small organization, you're thinking one expense to be approved, it is taking so much time. So how can you think about a big country with a billion population, how it can respond? But the kind of things, this is the vision. I mean, see, I have been with the multiple engagements, so now I'm able to relate what is the vision, why they are doing this, right? So with this vision, they have increased the income tax due to demonetization, due to bringing everything in streamlined. The income tax contribution has been increased. I mean, number of people contribution of so far salaried person we are doing contribution, but now each and every even business person, small business person is coming into systems, just because of everyone is afraid about I'm being tracked. I can, if I am doing wrongs, because I'm being tracked, government is having complete information, so any point of time I can be victimized. So it's better to be in system in proper way. So anyway, that's all. To dig a different story, we have to start with the architecture. So I think, do we have time? It's already 4 minutes over. So maybe we can. So guys, for this week assignments, what I would suggest. So specifically, we have few slides. You can definitely refer it. This is for your future reference perspective. Within the appendix section, you can go with the extra slides we have provided with the different use cases perspective, right? If you're going with the insurance, if you're going with the telecommunication, what would be ideal, use case and architecture, and how data flow is actually happening. You can relate these kind of architecture. So this is the extra slide, extra information we are providing for you guys. So manufacturing, and then oil and gas, data managers. So this is for information for your information perspective. Go with, try to understand, try to learn. If you have any question, you can come up with this any question in next class. And yeah, Ankur, we are going to share right away. You'll get email by today or by early morning tomorrow, this entire PPT. And on top of that, you try to contribute an LMS and try to write at least 50 line of article on what is the big data and what are the different use cases in the big data. What is the big data? Try to write this question. What is big data? And how what are the different use cases we have in big data, how Hadoop is able to help. So I'm expecting at least 50 lines of article, 50 lines. Just summarize your overall understanding. We talked already enough. You have material, right? If you want to refer extra resources over the Google, you can refer it. But just try to line of 50, not more than 50. You can go beyond 50, but minimum 50 lines should be there, right? So you post your answer over LMS. Correct. And then next week we are going to discuss about architecture. And once we are done with the, I think one day it will take with the architecture. And then guys, one day it will take architecture. Then yeah, next week you can expect. Next week we are going to discuss on architecture. So we have two core component perspective. We'll discuss architecture. Then we'll start with the quick session on Linux. And once we are done with the quick session on Linux, then you have to start with the HDFS, how we can deal with the HDFS. Then you have the assignment on HDFS, right? So after HDFS, then we'll start with the Java, quick refresher class on Java. Then you have to, then we'll go with the MapReduce, and then you have to submit Java assignment and MapReduce assignment. That is how we'll follow next few class, right? So, but try to definitely think, don't copy the content while posting your article over LMS. Don't match your content with anyone's, right? I'll be monitoring, right? So try to be in your language, try to reflect what you're understanding with the big data, what different use cases you can position, and moreover you try to relate with your current organization where you can position your, if you're someone from data center operation or IT support perspective, if you are there, then there is very good use case of big data analytics to manage the tickets, right? So if you are getting any tickets, right, tickets, any issue happening, so in a support system, whatever the issue we have user, you are getting issue in the form of tickets, right, in form of service request. So automatically, rather than having manual intervention, what is the best solution going to apply for this particular use case? There you can place big data and analytics, right? You can relate using machine learning algorithm. You can relate. You have set of solutions already available. You got SR on fly. You are relating set of the SR or ticket or problem with the already available solutions, and then you are recommending, please try with these solutions. Your problem seems related to this solution, right? So these are the different from IT organization, IT support, or data center operation perspective. Try to think, uh, think out of box. Whatever I talked about, so you can definitely relate it, but try to relate the organization you belongs to, domain you belongs to, right? Thank you very much, and see you next class.
Thank you.
So as you mentioned for the standard, if we have 4 GB of RAM,